And testing, yep, that seems good. And does this, yep, that seems good as well. VS Code is ready to rumble. All right. All right, hi everyone. Welcome back to COMP1531. Thank you for joining me on a Thursday afternoon. It's almost Friday. We're almost at the end of the week. We're slowly getting through it. But today we've got two more fun topics to cover. Two topics and then we can all have a nice long weekend. Anyone here doing anything super exciting over the weekend, like sleeping? Yeah, that's the stuff. All right. Before we begin the new topics, I just want to clear up something from the last lecture that I think I may have made slightly unclear, and that is the difference between TSX and TSC. So let me just, 3.3 linting. Now the reason I got confused is that TS is short for TypeScript, and TSC sounds like it should also be short for TypeScript, but TSC is short for TypeScript Checker. So that's what runs the checks. So if I go, oh, I hope I have do I have my npm command set up? I might not. Where's my scripts? Don't have my script set up. Microphone? Yep. I'll go back to 3.2. So with my first TS here, if I go npm run tsc, I'll go with my second .ts, my second ds.ts. All that does is that it performs the TypeScript checks. The reason nothing is outputted here is that there are no issues with my TypeScript, so it's happy with me. So that's what TSC does. It is the TypeScript checker. Now TSX is because the people who wrote TypeScript were very cool and they figured X could stand for things instead of E. So TSX is execute, because we're radical like that. So npm run TSX actually executes the code. It also does some checking, but TSC is for when you want to do the checking. TSX is when you want to execute your TypeScript code. Hopefully that is more clear than when I talked about it in the lecture yesterday, or on Tuesday. That's a quick summary of TSC versus TSX. Now, 3.3 linting lecture demo. All right, now we're going to talk about linting. And the reason we do linting is because we can't manually fix our style forever. TSC is great, TypeScript is cool, because it tells us where our style is bad, but we still need to manually go through and fix every single style problem that TSC tells us exists. And having an automated approach to fix this would be much more consistent and reliable, because as I've said in the last lecture, sometimes we're tired, sometimes we're lazy, sometimes we miss things, and so where we can, first of all, where we can, it's better to fix things statically than dynamically. And then when we can, it's better to fix things automatically than it is to fix them manually. Because as soon as you introduce manual things, you're introducing a human, and humans are famously very good. Thank you, microphone. Humans are famously very good at cutting corners if they want to. So linting is a form of an automatic style checker. We're going to talk about linting in general, as well as the specific linter we're going to use, which is called ESLint. So the reason it's called a linter, who here wears clothes? All right, very few hands up, I'm concerned. Most of us, right? All of us? All of us. And sometimes when you wash your clothes, like the little bits of lint get stuck on them and it just is a bit unnice and ugly and we need something to get rid of the lint, make everything nice and pretty again. That's what a linter is. It's like a lint roller, but for your code. You roll it over your code, it picks up the little problems, and then you can go about wearing your nice shiny piece of JavaScript. This metaphor's perfect, actually. So code style in of itself is a bit of a contentious issue. We say that programs must be written for people to read, and just incidentally, machines can also execute them. This was said by Alberson and Sussman. Normally I like to include a second quote, but I couldn't find a funny one this time, so we're just going to stick with this one now. Their philosophy is that when we're writing code, it's most important that someone else can read our code later, because I've said a few times that when we do software engineering, when we do programming, we are programming for people because people will use our software. But not only that, people are going to work on our software. People who work on it after us aren't going to be magic people who can immediately figure out exactly what you meant and figure out exactly why you've done things the way you have. And so having code style is a great way to reduce the cognitive load put on people who have to work on your program later. We've all met our teams, I assume. We all understand that when you're working in a group of 5 people, it's possible that everyone might have a slightly different idea of what is good code style and what isn't good code style. And you need some way to make that one unified vision to ensure everyone's working in the same mindset and with the same set of rules. So we care about coding style because it makes things easier for us to follow. It's easier to identify if things are similar patterns. It also makes it easier to detect bugs. If everyone's following the same style, bugs suddenly jump out a lot more clearly. And I'll do a demonstration to just talk to your neighbor real quick about these 2 bits of code that I've written. They do the exact same thing. Tell me which one is easier to read and comprehend. Chat with your neighbor real quick and maybe chat about why this is the case and what it is that's making one bit of code easier to read than the other. I'll give you a quick second to chat about that. Let's post the slides, please. I've been told the slides are posted. Rani told me she pushed them, so if the slides aren't online, I'm sorry about that. I thought I posted them. Right, so who thinks the one on the left is easier to read? No? Almost got me. Who thinks the one on the right is easier to read? Yeah, is someone willing to tell me why they think one is easier to read than the other? What are some things? They're both functional. They're both JavaScript that JavaScript will allow you to JavaScript. But what makes the one on the right easier to read? Yeah. Yes, indentation. JavaScript and C, for that matter, don't actually care about indentation. Half the time they don't even care about new lines. So you can just put everything you want in one big line with semicolons all over the place and brackets all over the place. And there's actually a contest every year for writing the most obfuscated piece of code that you can. That's not the contest we're having in COMP1531. But if you have indentation, it makes it much easier to see what level of logic you're working at. You can see if you have code that might be a bit more inefficient because you have a loop inside a loop inside of a loop. So yep, indentation is one of them. Anything else? Yep, variable names. Variable names are very important. If you do good variable names, it reduces the cognitive load to understand what the program does. And if you choose bad variable names, people spend a lot more time trying to figure out what's actually going on. If I didn't tell you that these 2 programs were actually the same thing, who thinks they could have figured out that they, in fact, do the exact same thing? And I'll prove it real quick. Probably the call down the bottom might have given it away. So if I go to 3.3 linting, is this my style bad? Yeah. CD dot. And I go node stylebad dot. Now, why did node not work? Can someone tell me? What did I do wrong? I tried to run a TypeScript file using node. That's not going to work. Let's try npm run. Oh no, this might not work because I haven't actually got my script set up. No, I don't have my script set up. One moment, sorry. Let me just... steal my scripts from here. Right. Let's try that again. Yeah, it has printed the word Survivor twice because this week is the second episode of Survivor that I'm going to watch after this lecture. And this good program is the exact same but with indentation and with better variable names, and if I run that with npm run tsx good.ts, it does the same thing. So even though this one is ugly and all over the place, JavaScript's fine with it. I'm pretty sure I can even do, can I do this? Surely. Do that, maybe do that. I reckon I can do that as well. Yeah, let's see if JavaScript lets me do this now. Yeah, it's happy with that. What if I think this might be pushing it. Let's find out. Give me a new terminal. Went to the wrong directory. Yep, it's still happy. So you can get pretty cursed with what you're doing with your JavaScript and with your C. So what we need is some way to tell you, hey, stop doing that. But who thinks that the decision on code style is up to a single person in their group? Who thinks that the decision on code style is up to me? As in literally me. I decide what good code style is. It's all me. No, it's a group effort. The decision on what is good code style in your project is a group effort. It is actually, as long as you're following style that is consistent within your group and follow reasonable conventions, we're going to be happy. A few lectures ago, I mentioned a style guide, thinking that there was one, much like in 1511. There's not a strict 1531 style guide. It is follow conventions within your group, that makes sense, and be able to justify why you've used them. If you do want to use a style guide, which maybe you should because style guides are good and make it a lot easier to back up why you're doing certain things, Google has a style guide specifically all about JavaScript, as do Atlassian. No, that's not Atlassian, different style guide. We'll quickly dive into one of these style guides, and I'll point out that you may not need to worry about everything in them. So if I go to the Google JavaScript style guide, for example, make sure your file names are encoded to UTF-8. Maybe you won't need to worry too much about that particular rule. Or if I go all the way down to the bottom, there's going to be something fun here. When declaring an anonymous function in the list of arguments for a function call, the body of the function is indented 2 spaces more than the preceding indentation depth. That's actually pretty reasonable. Actually, now that I look at this, oh yeah, trailing commas, include a trailing comma. Like if you say to yourself, actually I don't like trailing commas and our group doesn't want to include them, that's fine. You can break the rules as long as you can justify why you're doing them and as long as you're consistent within your group. Have a dig through these style guides to see what you do agree and disagree with, and decide amongst yourselves what you're going to be following as a group, because that's the most important part, that everyone's on the same page. Yes, so manually checking our style every time we write code is quite annoying and bothersome, boring. I couldn't have said it better myself. It's inconsistent. And in software engineering, we're going to run a linter, which is another form of static verification. Who here was just sad we didn't have enough static verification yet? Don't worry, we've got more. Yeah, they pick out the loose threads in our code, much like regular lint. Yep, static analysis. I've sort of already said these points. It can determine style issues, so things like bad indentation, improper white space. It can determine your variable naming issues, sort of. We'll get more into that briefly. It can also point out semantic issues. So for example, if you have a while loop that has a break inside of it, inside of an if statement, your linter might say, hey, hang on, that's a while loop that may end up never terminating. Or if you have a function that returns in one branch of your if statement but doesn't have a catch-all return at the end, it might say, hey, this is a function that may never return or may return something improperly. So it can not only catch style issues, but also issues in your program's logical flow. Now it does sort of have rules for variable names, but whether or not something is a poor variable name is an incredibly hard issue for us to solve in the world of computer science. Because basic rules like ensures something is no less than 3 letters long. Suddenly, if we're working with coordinates, variables like x, y, and z, which make sense in that space, are no longer allowed. And variables like cool guy, that's more than 3 letters long, probably not going to be that useful. If you really want me to rant about variable names, I do a lot of research in this space, and I talk about student behavior when it comes to variable naming. I've been researching high school students recently in terms of their variable naming conventions. If I see any of you write the line FIVE equals 5, I'm gonna be really pleased about it. It's the most common mistake high school students make. Anyway, moving on. So we're going to specifically be using a linter called ESLint, which is a linter designed for JavaScript. If you've done Python in the past, you might have used PyLint before. It detects errors, warns of potential errors, and checks against the conventions that we decide. The thing about linters is that they have lots of rules they can check against because there are lots of standards in programming. We only really care about some of them. Another cool thing about ESLint is that it can automatically fix these issues. It not only tells you what these issues are, but in cases where it can, it will actually fix those for you. While you are able to configure it to be as strict or as lenient as you want, in reality, this should say, will be configured by the COMP1531 team to be as strict or as lenient as we want it to be. We'll get more into the configuration later, but we will be configuring ESLint to match what we think is some good rules for you to follow. Of course, we need to install it. We need to install everything in this course. So let's use npm install -- save dev ESLint. And it's save dev because we are using it for development. It's not something that our users need to worry about. My lecture demo, npm install -- save dev ESLint. And now let's make a JavaScript program. Let's make a new file called lintexample.js. And I'm going to go let x equal 12 if x is greater than 13, print no console.log hello, just some small example. And now I want to run my linter against it. So we need a command to run that. The command for running your linter, where'd you go? No, I don't have my commands in here. Oh, they're in here. Thank you. Oh, it's just ESLint. I'm just going to steal this. Scripts. There we go. So let's go npm run lint on lintexample.js. And what it couldn't find is a config file. So actually there's a few things we'll need to cover before we get into actually running our linter. The first is that what I was trying to show is that I was going to run it for JavaScript. But notably, we're not actually using JavaScript very much anymore. We've moved on to bigger and better things, if you have that opinion. So we need a few more packages to get it to work. Specifically, we need a TypeScript ESLint, which is a wrapper around ESLint that allows it to work for TypeScript. We also need to install the stylistic plugins so that we can check code style as well. Some more style rules are in that package. And we also need to make it work with Jest, because Jest is something we'll be using a lot of. So let's run these 3 commands as well. So this first one ensures that it works for TypeScript. The second one gives us some extra style plugins to play around with. And this third one allows us to make it work with Jest if we so choose. Now that we've got all of those commands, ESLint still isn't going to work because we need a config file. determines the way that ESLint works is that it reads that config file to figure out what rules it's going to run against. We use this, the file will be called eslint.config.js, and you can do the configuring yourself if you really want, but don't, because we will configure it for you. We will provide this file for you, it will be in your labs, and luckily I have a copy for me right here. So let's go, new file, eslint.config. It's actually .mjs, which stands for minified.js, I believe. I can't remember. Oh, where did it go? I had a copy, that's fine. One moment. Where did I specifically stored a copy of you? There you are. So there's a lot of rules in here saying that, for example, deals with dangling commas, checks for semicolons. These are a bunch of style rules that come from that stylistic plugin we installed, configured to work on both JavaScript and TypeScript. There's a lot going on here. You can dig into it if you want, but you do not have to. So now that we've done that, let's try again using npm run lint on our example. Oh man. Let's use the command node modules./bin and then our badstyle.js. And hopefully there is some way we can put this into a script later. So I'm going to copy this instead. Is it because I haven't saved this file yet? That could be it. And we'll run. And it's going to be on. There we go. Look at all of these errors I have. I have an extra semicolon apparently. Print is not defined. You guys let me put the word print in here and no one said anything? I'm so Python brained sometimes. Console.log tells me that it expected indentation of 2 spaces, didn't found any. Strings must use singletons. An extra semicolon somewhere. Console is not defined, that's going to be a problem later. Strings must use singletons, extra semicolons, and it even says that there are 9 errors, 0 warnings, and 7 of them could be fixed automatically. That would be handy. So as you can see, it went through and it not only found, so if nothing were to print, follow my stuff were allowed, would be good. But because some stuff printed out, there are some problems. And some semantic issues need to be fixed manually, such as that thing of print not being defined, because it has no idea what I meant when I said print. It said, you just called a function that doesn't exist. What are you doing? Style issues, we can choose to fix them manually if we want to, but it would be much nicer if we just automatically fix them instead with the command, this one. Let's see what it does. If we're lucky and we don't scare the file, we'll get to see it in action. That's not what my file is called. And look, it's added the indentation for us automatically. It's gone through and it's fixed all of the errors that it could. There are still 2 errors that it can't fix. One of them, and they're both the fact that console is not defined. That's a quirk of these Node, essentially, things normally running in the browser, but instead running in the console, and having console.log be an undefined function in this environment. But we will update the configuration to fix that. It is fixed for TypeScript. So in fact, let's try it with TypeScript next. Let's make a new file. Why don't we use SaveDev for those plugins? We probably could use SaveDev for those plugins, but because they go on top of one that's already SaveDev'd, it's not as big of a problem. How does it differ from COMP1531? Don't know, haven't done that course. Right, let's make a TypeScript file called example lint ts.ts. I'll make a function this time. I'll call it checks sum of a with what if I'm checking sums, what do we think the type of A is going to be in TypeScript? It's going to be a number? Nice. I'll go B, and I'll go number, and I'll go C, I'm going to make that a number as well. And I'll go if A plus B equals C, we can return true, else we can return false. And we can call this with console.log checksum, and let's go like 4 and 3, that's equal to 9.
Sorry, just to return A plus B equals C.
You're right, I could do that.
Just one line of code.
I could do it in one line of code. I didn't think of that. I'm not going to, because I want to see if I can get this working with example lint ts.ts. Now it's saying that there is one error. It expected triple equals, but instead sees a double equals. So we're going to start being a lot more stricter on those now. If you need to have triple equals, you should always use triple equals. It's much safer. If I do things like just get rid of my indentation, I don't care for it. And I run this again. It automatically fixed most of them because I had the fix flag enabled. I didn't mean to have the fix flag enabled, if I'm being honest, but it does show how handy it can be. So now let's run it without the fix flag. There are 6 problems, 5 of which can be fixed automatically. So it can't actually fix the double equals, triple equals thing itself, even though you'd think it could. So we'll run fix, we'll update the triple equals, we'll run it one more time, didn't save it, run it one more time again, and because nothing is printed out, there is no problem with our linting, and so we're happy to push. Speaking of linting, you can disable it. If you want to, you can put a command in like this to disable your lint for that next line. Who thinks that we're going to actively encourage you to do this? All right, good. Please, you are allowed to do this if you want, but you just need to check with your tutor first. You need to talk to your tutor about what rule is being pulled up by the linter, why you think that rule doesn't matter, and if they agree, they will sign off on it. So you can disable a small number of rules, but your tutors must sign off on them before you disable them. So if you really disagree with some of the linting stuff, you can sign off on it and disable it, but maybe just be sensible about that. There is a guide based on how to do the disabling. So that just disables the next line and then that disables it entirely and then re-enables it. I'll leave you to read that guide in your own time because I'm hoping you won't actually be disabling ESLint very often.
So,
yep.
Won't you have to call the function to call ESLint to apply this ESLint? Why you have to disable it?
So you can, it's for when you want to run the checker, but not all of the rules in the checker. So you can disable it for certain aspects of your code. So for example, over here.
You mean the configuration file?
This is for, you put this inside your actual program, and it says that it disables ESLint between these lines. So any errors that would appear between those lines don't appear anymore.
Oh, okay.
So you put it in your program and say that between these lines, I don't care what ESLint has to say, I'm right instead, 100% of the time.
Comment.
Yeah, in the specific format. The format does matter. Right, so typing those commands out manually was really annoying. Thankfully, we can have scripts to do them for us instead. Those scripts are very handy and I love them. You may notice a thing here that says backslash quote star star slash star star dot JS backslash quote quote. That is known as a regular expression. What it is saying is get everything that comes before that, get every file with a .js extension. In fact, yours will probably say .ts instead of .js. This one is for JavaScript. If you're using TypeScript, you can do another one. You can even have different commands because of how scripts in JSON work for if you want to run ESLint on JavaScript or TypeScript files. Don't worry about the regex. Regex is scary, and the entire internet went down because of a bad regex one day. But just know that that's what that does. It gets all of the JS files, and so if you want, you can even run ESLint on just everything. So if I make a second TS file called second.ts.ts and just console.log hi, but maybe forget a semicolon on the end. If I run, let's go to my package.json. Yep, that is .ts on the end. And I'll go clear, npm run lint second ts.ts. Yep, there are some errors. And if I just run npm run lint, it's going to match every single file in my directory that ends in ts and show me in both files where all the errors are. So that's what that regex does. It picks every single thing with .ts on the end and runs it. This is really handy. It would be really good if we could somehow like force this to run on everyone's code whenever they push it. That'd be like a really handy thing we could do where when someone pushes their code, the style check is run automatically and they have to deal with it, otherwise they're not allowed to merge into main. Oh hey, remember that thing we learnt about recently that means people's code has to run against a certain set of scripts, and if they don't get a green tick, they can't be pushed into main? Wouldn't it be? I'm seeing a lot of not recognition on people's faces. You all remember it, and you all are really excited about it. Now we can add a new rule to it. We can add a rule for the linting stage. I just wrote very cool. Nothing else to say. No, so let's go to an example I made before this lecture on 3.3 linting. If I go to my Git repository and I go to 3.3 linting, what you will see is that I currently have a green tick, which is great, because in my CI YAML file, I added a linting stage during a linting pipe during the check stage, which runs first npm install and then does npm run lint. But in this, if I do npm run lint right now, where did my config file go? What? Like it's there. It's. Let me try git pull. I'm not going to try git pull in because I might break something. No, I should definitely be git pull in. That's how you do. That's how you git. Let me try git pull in and see what comes up. If I end up having to untangle a git mess, it says it's up to date. Where's my config? All right. ESLint.config.js. That's not what it is. It's .mjs. Yeah, ESLint.config. Let me. .mjs. Is that going to be the copy button? Copy that. Save you. And now let's run that again. And now I've got some errors. So what I'm going to do is push. Git add all. Git commit -m. Linting is for nerds. Git push. And so what I refer to myself as right now is just, standard student. Am I right? No. Right, so now it's being run. The linting phase is being run in the pipeline. It is installing all the things we need it to install. going to take a while to run because it does need to install everything. Maybe it'll pass. Aww. And now all of my teammates get to know, hey, Henry, why would you do that? Why would you try to merge this into main? In fact, I did just push this straight into main, so I probably shouldn't do that in the first place, but if I were doing a merge request of some kind, my teammate could look at this and immediately see the red tick, the red X, look at the pipeline and say, hey, you failed the linting phase. The thing that automatically fixes your code style for you, you didn't even run. And you would send it back and you would say, could you not? Could you instead maybe run the command npm run lint fix? It's on everything. Now there's only one error that can't be fixed, which is in stylebad.ts still. This is the only thing it couldn't unpack for me. And the only reason it's unhappy is because you are allowed at most one statement per line, and I had 3. So let me just run the lint fixer again. Okay, it's all fixed up. Let me just git add all, git commit minus m. Maybe linting is cool. Yeah, that's how you spell. And now my pipeline is pending. While we wait for it to run, I'll just check chat. They say we're allowed to use regexes. Regex, right? Yeah, you can use regexes if you want. I'm just more of the opinion that that's scary. Someone in chat asked if they're allowed to use a regex in their project. You can use a regex in your project. Feel free to if you understand what they are and how they work. If you don't understand regexes and how they work, and you're trying to solve a problem with a regex, you're going to have 2 problems now. And I've got my green tick. Woohoo. So we're going to be introducing linting in week 4 onwards in your labs. So we will be expecting your style to be a bit better. We will give you that configuration file I talked about. So you won't need to worry about writing that yourself. We will also actually add the lint commands to package.json for you. And we will add the lint command to your gitlab.yml as well. So we're doing a lot to make you up to speed as quick as we can. And ESLint is going to be part of the project from iteration 2. So once iteration 1 is done, ESLint will be part of the project and we will be wanting you to run it. And you should be running it because it just tells you where all of your problems with style are. And that makes your life so much easier. And we'll also be giving you the configuration file for that. But for the iteration, you'll need to add the commands to package.json yourself. If only there were like some labs you could base it off, or maybe some slides provided by the lecture that you could base the commands off. That would be really handy and make this much easier for you to do. You'll also need to add your own lint command to your continuous integration. Again, it would be really handy if the lecturer just showed you how to do that and the slides are available. Hello.
Could we put ESLint before iteration 2?
If you want to, I'm not going to stop you. Yeah? Do you? Yeah, go for it. If you want to use ESLint earlier, go ham. But if it's getting close to the wire and things are not working and you go to yourself, you know what, I'm going to put ESLint in now. Your team might be upset with you. So priorities. I already went through this. There's a lot of things you need to install. I already talked about the 3 of these things. Installing them is necessary to get ESLint to work in this course. And as I talked about yesterday or on Tuesday, do not stress the minutiae of all of these packages and configurations and what these scripts do. The scripts are important, but the things like the config files and how they work and what they do and how a linter works exactly isn't important. What's more important is that we need you to understand why we're using linters and the general reason behind them and why they're a good idea and why your team should be happy that we've introduced them. We don't expect you to be experts in tweaking random environment variables to get particular things to work. You just watched the lecture. You saw me fail to get environment things to work for about 3 minutes there, and it can take a lot longer if you're less experienced. Right, I know that's a bit early for a break, but the next section is all about HTTP servers, and that's a bit of a longer one with a few more slides. So what I'm going to do is I'm going to say we're going to take a 10-minute break now. We're going to come back just before 3, and then go for slightly longer in the second half. Sound like a plan? All right, cool. If anyone has any questions, please feel free to ask or come up and have a chat. Otherwise, I'll see you all in 10 minutes. Thanks, everyone. it is a good time to stretch your legs and whatnot. All right. All right. It appears that we are so back. It's been 10 minutes. Hope you all had a good break. Let's talk about one of the denser topics in the course, which is HTTP servers. So we've talked about JavaScript sort of as a complement to C and JavaScript as its own programming language. But the reason that JavaScript was built was for HTTP in a way. It was for transferring things from one person to the other, or from one place to the other on the internet. HTTP stands for Hypertext Transfer Protocol, and JavaScript, its initial design, the thing that it was designed in that 10 days to do, is to send and retrieve documents between people. So someone far away would have a document, I would send them a JavaScript request that said, hey, can I have that document? And then they'd send the document back to me. And that was the whole point of JavaScript. And now it's become what the internet is run off, and that scares me. So basically, a lot of the internet runs on some form of HTTP, be it HTTPS or a different network protocol, but we will learn a bit about HTTP in this course. It's fundamentally designed for sending and retrieving information online. So we'll talk a bit about networks very briefly. We'll talk about what Express is and what an Express server is and how we can run those. We'll talk about what APIs are, and we'll talk about CRUD, which stands for Create something, Update, Delete. I can't remember what R stands for. Don't need to worry about what CRUD stands for. Create, Retrieve, Update, Delete. There we go. So a network is a group of interconnected computers that communicate with one another. So UNSW has a network. It's all of our computers in the labs. They can all communicate with one another. The internet is a global infrastructure of networking computers around the world. So when I say computer, you may think I'm thinking of this MacBook in front of me. This is a computer. But actually things like routers in of themselves are tiny computers, and they are part of the network. The information goes to the router and then gets sent out to the world, or actually gets sent out to another router and then another router, and it makes a series of hops to get from one place to another. With the magic of Wi-Fi, it's easy to think that my computer will be directly beaming to YouTube when I'm streaming, but in reality, all of the packets that I'm sending are making a series of hops from one place to the next until they eventually get to their destination. So it's that interconnected network of computers all around the world. And the World Wide Web is a system of sending information and resources that are linked together and accessible via URLs that we type into the browser. So it seems easy to think that these three things are the same, but they are different in their own unique way, and they are distinct from one another. There's a lot to learn about networks, about the internet, and about the World Wide Web. It's enough to be its own course, and so we can't touch on it all right now. And in fact, if you do want to learn all there is to learn about networks, the internet, and the World Wide Web, there is a course for you. It's called COMP1531. So if you really like the idea of networking and HTTP servers and all that stuff, you can take that course. Right now, we're going to do more of a crash course on it. One thing that we've sort of hammered home in this course is that people always need to be on the same page. If people aren't on the same page, then projects don't work and things don't work, and it all goes into anarchy. And it's the same with the internet. Imagine if everyone had their own set of standards for how to send and retrieve information on the internet. It would fall apart and we wouldn't have the internet. Maybe that would be better, but that's not how it works. Networks need a structure that everyone not only understands, but they all follow and agree on. And humans have structures as well. Like if I go up to you and offer you a fist bump, surely you're going to like fist bump me back. Yeah. Yeah, oh no, someone just tried to high five me in the back. That's so sad. Or like if I wave at you, you know that I'm saying hello, and if I go to shake your hand, I'm being respectful, unless I use my left hand for some reason, in which case suddenly that's a bad thing. Waving, clapping, handshakes. These are all protocols that are used for different kinds of communication and expressing what we want. HTTP is one of the protocols used by networks. It is accessed by URLs in the browser, and we can actually see in our browser, this is going to get a bit recursive for you. If I right-click, oh, come on, yeah, if I inspect, and I go to networks, perform a request. What if I reload the page? Suddenly it tells me all of the different requests that are being sent across the network, and what the status codes are, what those requests are. We'll learn more about some of these requests briefly and what these codes on the left actually mean. Some of them aren't failing. I'm trying to post things and I'm not allowed to do that. But HTTP is used on every website, and if I go to a website, a bunch of HTTP requests will happen. There are other network protocols. So there's TCP, which is used for things where it doesn't really matter if things get lost. There's UDP, which is when, oh no, it's the other way around, I think. No, TCP is for when things are very important, and UDP is for when it doesn't actually matter if it gets there or not. But we don't care about all of these. I'm just showing that they exist. We are only focused on HTTP right now. So while these exist, I don't expect you to learn pretty much anything about them because, again, this is not a networks course. So while these network protocols exist and you may have heard of them, we are only worried about one right now. Web browsers and applications request and receive information using HTTP requests. But where are these requests coming from? If I'm just clicking on links, how is a request happening? If I just want to go on, I'm not going to check my emails on stream. I can't think of anything safe to do on the internet while on a live stream.
YouTube maybe?
No, you'd be surprised. No. If I come to my network and I click here, a bunch of requests happen. So everything on the internet comes in a series of these HTTP requests. And the reason that they happen is because actually URLs are not just random strings of information. They're not just random strings of letters and numbers that are meaningless. They actually store information about what we're asking, where we want to go, and much more. So if I go to the URL here, you can see that currently I am in lectures 3.4 HTTP intro tree main. If I get rid of this part here, it takes me out to this part of the website. So these URLs are actually where the information that your browser is looking for gets stored some of the time. And if I were to add maybe 2.2 multi-file importing, you can navigate the entire web without actually clicking on anything if you know what the URLs are, because all you're doing is sending information that the browser can read and tell you where to go. You're doing routing with those. And we can run, these are all run on HTTP servers, and we can run our own using the Express library. Of course, we will need to install the Express library, which will be done with npm install express. So let's do that real quick. Actually, I already have it installed. Cool. And now we can run our own Express server. This is an Express server that I've spun up right here. And there is quite a bit going on, a lot of new stuff in here. So I'm just going to go through it almost one line at a time and go through what each chunk of code does, why it's important, and why we need to worry about it. So we'll start right at the top. This line of code. Who knows what this one does? Yeah, a few people. It's importing Express from Express. You should be happy with this concept. There shouldn't be this, if you're not, please do revise the lectures on multi-file and importing as well as package management, but this part of the program should be relatively straightforward. Next up, we are creating an Express app on our local host. So if I go to the website, literally localhost, that's where our Express server is located. Now it goes onto a port, and that port number is 3000. And a port is essentially a road in and out of your network. Some websites have thousands of ports, sometimes it's listed on port 88. And so think about it like, who here lives in an apartment? Anyone? I live in an apartment. It's crazy because New Zealand doesn't have apartments, so this metaphor never worked for me until now. There's no people in New Zealand. There's more people in Sydney than there are in New Zealand. Isn't that wild? So the reason we have things like ports is that I live at an address, which I'm not disclosing to you. But I live in a certain part of that address. And so I'm saying, well, you deliver things to my apartment building at that address. It's the same with ports. Lots of things may be stored on that IP address, but we only care about one particular port right now, one particular apartment complex. Next up, we say that we're going to our Express server, which is called app, is going to use text. So we are passing plain text into our Express server. We can pass JSON instead. We will mainly use JSON in the future. We'll talk more about JSON shortly. Hopefully you're relatively familiar with it. It's a type of object in JavaScript. There are other options, but you're mainly going to focus on JSON or plain text. Next up, what we're saying is that when you go to the URL with /hello, so if you type localhost :3000/hello, we're telling the server this means you're wanting to do a get. Right, and that's what that on the left part says. You're doing a get. When we do commands HTTP requests, you can have either requests or responses. And so what we're saying is that we're going to send back a response that when we go to the hello place, when we go to the hello part of the URL, we're going to send back a response that says hello. So in fact, let's spin up our server. I'll make a new terminal. I'll go node express basics.js. It's listening on port 3000. I actually need, okay, so now I don't need a new terminal. If I go to localhost 3000, there's nothing here because there's nothing on the home page, as it were. But if I go to /hello, it sent me back a response. It said hello, it sent it back to me. We didn't say put the hello there, we said just send back a response that says hello. And that's what it's done. Now we have a second path where if someone goes to the path whats/up, another GET request is going to be sent. But what we're sending back is a JSON, a stringified version of a JSON. JSONs are objects. They come with key value pairs. This one is a JSON with the value of not much. So let's try that now. I said hello. So if I just go to whats, there's nothing there because there's nothing to get on the whats URL. If I go to what's up, now I have a JSON back, and it's telling me, well, the value of what's up, that's not much. What's up with you? You will become very familiar with the function json.stringify because it is how we need to send things back and forth quite a lot of the time. Because normally JSONs themselves are too complex to send. We turn them into strings, then we send them, then we turn them back into JSONs and read them. At the bottom, that's actually starting the server. So it's saying we're going to listen on that port. We're going to start monitoring for traffic. And we can call the server both via the browser and via this thing called curl. So there's not only just using things by going through the URL, we can send things via the command line as well. So if I go to that's not what I wanted. Go away, Ravine. No, I've opened all of my messages, so hopefully someone can pause it and just read everything I've said to everyone now. So if I make a new terminal, see over here on the right, there are two terminals. There is this node terminal, which is still listening on port 3000. So our server is still running right now, even though I've started a new terminal. And over here, if I go curl localhost 3000/hello, I get hello back. And if I curl localhost 3000 and I go to what's up, I get not much back. So you can imagine if there was some way to do this in code, we could send requests to the server, then based on some conditions, it could send us information back. And then based on some more conditions, we could send information back to the server again, and it could send us information back, and then we could send it more information, and suddenly we're talking back and forth to one another in this HTTP server, and suddenly we've got a website. I'm going to take your stunned silence as you're blown away by the concept of, yeah, this is how websites work. Isn't this exciting? I'm excited. That Survivor's on later tonight. No. So yeah, what are servers for? Is it just for sending hello and WhatsApp back and forth to one another? No. In the past, it was just for sending documents between browsers, but now servers do exchanging large amounts of information. Everything that gets displayed on your page, on your Facebook page, for example, Facebook is sending a request. Well, you're sending a request to Facebook that says display my profile page. It's sending back all of your profile page information. It's then running some code to put that in the right spot in the browser. Then you click on another link, you're sending a request to Facebook to, is poking still a thing on Facebook? To poke your friend? Everyone poke a friend on Facebook tonight. Am I old? Maybe. And it's sending a request to Facebook to do that. And then it sends a request to your friend's browser. It tells them that this has happened. And it often happens not just via the URL, but also by using APIs. And it's usually done in the form of a JSON, because we've been just doing plain text right now, but normally we use JSONs for this. Now, I've just shown that you can go to URLs and you can get information out of them, but what if we want to actually send some useful information and do something with our server and actually send stuff to Facebook to tell us about what we're doing? We can convert objects into JSONs. This is typically how servers have sent and received information in the past. So, if I go to, where are we? Express.json, and I clear this, and I'm going to have to shut down this node server.
So just as a
Yep,
small
question?
So, based on my understanding, the arrow thing,
Yep.
it's like it created a nameless function.
Yes. So this arrow here, this syntax here, is very common in JavaScript, and it says just create a nameless function, create an anonymous function. Anonymous functions can still have parameters, it just doesn't have a name, so it can't be called anywhere else. It's tied to the function that it's a parameter of. JavaScript is so weird letting you do that.
So the parameters are request and response.
Yeah.
Okay.
So now let's boot up a JSON version of the server. Let's go node express.json.js. Now I'll make another new terminal. Go into curl, localhost 3000/watts/up. And it sends me back the proper JSON version. So now it is actually a JSON being sent back to me. And if I try to go on the actual URL, this is now a proper JSON. You can see that it is the JSON version, and that's the response that we're getting back. It's not just some text on the screen anymore. It's an actual object we can interact with. Well, my phone has gone. So any questions in chat? Why has chat done this to me? Nope, no questions in chat. But that's not the only way that servers can send in and receive information. We can also send information as query parameters, which can be passed into the URL. You may see this all the time. If you start looking at URLs now, you'll see query parameters all the time. For example, that feedback form at the end, if you scan via a QR code, it will put at the end, I think it's access equals QR code, which means we can figure out how many people are accessing the form via QR code versus how many people are accessing the form by clicking the link in the forum posts.
UTM equals to.
Yeah, yes. And most people aren't clicking them in the forum posts I read, because as I found out on Tuesday, people aren't reading my forum posts. Oh. So let's make a new server. Stop opening that, Henry. So I've time to spin up a new server. It will be called node input query.js. It's listening on port 3000, and now when I come to my URL, I can just add name equals Henry and age equals 42 on the end. What am I passing into? So the URL that I'm going to is my/URL. I believe if I just do that. Yep. So now that I've done this, it has taken these query parameters from the URL and put them into our JSON for us to look at. So if I go through this bit of code here, it says that the name it gets is equal to the request.query.name. So that's saying that if someone in the URL goes $name equals, that is rec.query name to JavaScript. Same with AIDS. If someone does $AIDS in the URL, we get request.query.aids. And then we put them into our JSON to look at. What I'm curious about is what happens if I don't set AIDS or name. So let's not set AIDS and see what happens. We just get AIDS as undefined, which is different than null because JavaScript loves to do the different things between undefined and null. So we can also send information to servers via query parameters. Not only that, we can send it, we can just pass it in directly as parameters in the URL. So if we do a similar thing to last time, but we just put /Henry at the end, what am I doing? Something's wrong. I'm just going to quit this. You know what? I'm just going to like unpin this from my doc because clearly I can't be trusted. Just go away. All right. It's been too many times, too many strikes. So now we'll make a server called, I don't want to ask the AI question. Oh, what the hell? What the heck? What? All right, that you saw me. I didn't click anything. Teams just decided. That's wild. My computer might be cursed. Do you reckon I can convince the university to give me a new one based on that? Right, I've spun up a new server, which accepts name as a parameter this time. And now we've set name as Henry because it is the last thing in the URL. It is a param that you can just set to be whatever you want. It's similar to how the URLs work here, where this over here is a parameter, but it just needs to be a parameter that actually exists, otherwise it can't go there. So let me change name to be, I don't know, Teams is cursed. Can I put underscores in here? Let's find out. I can. Who thinks that I can put spaces in here? Any bets? Yeah, Firefox is happy with that. That's wild. What did you say it converts it to?
Isn't it %20? I forgot what it is, but it's the space character representation.
Yeah, there's a space character representation in some browsers, or in all browsers, called %20, I'm pretty sure. But in Firefox, it just lets you do that. I love Firefox. It's such a good browser. Now, we've been doing app.get this entire time, but we can use app.post instead, which passes information not over the URL, but through a body instead. The reason we want to do this is because sometimes there's just too much information to pass in the URL, and doing things like typing Henry and then space and then Teams is cursed and passing all of the different parameters in via the URL isn't always practical. So we're going to use app.post instead to send it via the body. Except if I'm sending it via the body, how am I actually going to send anything? Let's think about this real quick. So we're going to go here. We're going to kill our old server again. Post example.js. So now let's go to /hello on our local host. But we can't, you can only do get commands in the URL, and we're trying to do post instead. So we need some new way to talk to our server. We need some sort of way to do it programmatically. And we can't just use the URL for this. And so now we're getting deeper into HTTP methods. This is where the CRUD acronym comes in, which I've cleverly ruined here. What is happening this lecture? Is it my MacBook? All right, sure. Sure. So I like the order of get, post, put, delete, and only just now, looking at this slide, do I realize why it's normally not that order? Because if you put post above get, it actually spells CRUD. If you also make delete, just say delete. I've really really gonna ruin this acronym. But there are 4 main HTTP methods. There's get, which is where we want to read information. There's post when we want to create something new. There is put when we want to update something that already exists. And there's delete. You can figure out what delete's for. Those are the 4 main HTTP methods. And you can use, these are the ways you can use them. There's rec.params is accessible for all of them. Rec.query is only good for get and delete. And rec.body is only good for post and put. Because with rec.body, we're sending information to be updated. And with rec.query, we're asking for information either to get it or to get it and say, you can't have it anymore, please delete this. This is becoming, this workspace is now randomly opening drawers into me. There are more commands than just those 4. So you can patch things if you need to do an update. You can trace things, but we're not worried about all 9 of them. We only care about the main 4. We care about getting, posting, putting, and deleting. And the way we're going to interact with things now is not with not doing it through the browser. We're going to do it via APIs. API stands for Application Programming Interface, and it's actually the way a lot of things on the internet work. Because doing things just by sending information over the browser isn't handy, and it's really good if computers can talk to each other in a way that computers can understand, even if it's slightly harder for humans to write it. It's used to programmatically exchange information with interfaces. APIs are really useful because a thing that is really handy when you're doing research is things being in a consistent format. Before APIs, people used to build these things called web scrapers. Has anyone played around with web scraping before? That's where you literally go over the website and try to pull things out of the physical website itself. You try to go through the document object model and extract information from that. The problem is web scrapers are extremely volatile and fall apart as soon as anything on a website changes. Who here has really enjoyed an interface before and then the website updates and that interface just got completely ruined? Is anyone? I've experienced that many times. And it's especially bad for people when they're trying to do web scraping because now all of their web scraping tools just don't work anymore because of that interface change. APIs means that we have a consistent way to pull information off of the internet or send information to the internet. I've used it before when I wanted to get data from Google Sheets because Google has a Google Sheets API you can pull data from. One of my favorite uses of APIs is my dad wanted to know all of the people who he followed but didn't follow him back. And because he wanted to unfollow most of them. So I used an API to get the data from the people he follows and people who follow him and figure out which people are, in his words, traitorous. Yeah, of course. I've used it to get data off the Survivor Wiki for analysis, not related to my research, just related to having a good time on a Friday night. APIs are everywhere and they're very handy because they allow the internet to actually work in a smooth environment, in a smooth way. Much like we have network protocols, we have APIs to allow us to retrieve this information in a way that people can understand and actually work. So yes, so some standard API requests, I might say to the server, load a web page for me. And the server will then send back the loaded page. That is an API request. I might say, okay, I want some extra data, and it might then send me back, okay, here's the extra data for you. And it's this talk back and forth of, hey, here's the data for a form you wanted, and it will say back to me, oh, that form has been submitted. The most important thing with the internet, and actually a problem for you to think about, is we need to be able to confirm this sort of back and forth handshake. Because I need to know, the reason the server's sending things back is that I need to know that it's received my information. But then from the other side, how does the server know that I've received its acknowledgement? I've sent it information, and then when I get a response back, I know that it received my information. But how does it know that it received my information? I could send back a third thing saying, okay, I've received the information that you received my information. But then how do I know that the server received the information that I received the information that it received my information? It can send me back another one, but you can see where this is going. This is called the two generals problem, and you will learn more about that in networking again, but it's a really fun one where at some point we just need to trust that we have received the information and it's probably fine. Now we're going to be using a specific type of API called a RESTful API, and it's called RESTful because it only uses those 4 HTTP methods: get, post, put, and delete. And these describe the nature of the API request that we're going to be making. Don't worry everyone, I know you thought that we hadn't installed enough NPM packages today. Don't worry, there's more to go in your package.json file. We're going to use sync request curl. That curl I was using before is now part of JavaScript. And so now we have a slightly more complex server, and I'm going to go through it and break it down and not open Teams again. Now this is a server called books. So much like before, I'll zoom in slightly. We're importing our Express. We're setting up the Express server. We're using JSON, and I've made an array called books because we're going to be putting books onto the server. This is a post method. It asks for the body to contain the title of the book, the author of the book, and the year that that book was published. It checks if the title exists, the author exists, and the year exists. If none of these things exist, it returns a 400 code. We'll talk about more what these codes mean shortly, but know that 400 means that there is an error. See, it even says what the error is, missing fields. If that error doesn't happen, it makes a new book, and it adds that book to our list that we were talking about before. We also have a get method, which gets books. It just returns a JSONified version of the books. And lastly, we listen, and we don't judge. No, we listen on port 3000. So let's go node, books.js. We're listening on port 3000. What I've also got is this, called request.js. So instead of making my own request via typing it out, I've programmed a request to make. So I've imported sync request curl for us to make that request. I am saying that my result is whatever the result of this request is, which is me posting a JSON object to this URL. So if we go back to our server, we can see that posting to books is allowed. And I'm trying to post to books here. So these match up. This is good. I'm passing in the JSON welcome to sends with the author being 1531 because that's us. And it was published in 2025. Then later, after that, I'm going to make a second request in which I just try to get the list of books. So we're listening on port 3000. I'm going to make a new terminal. And I'm going to go node request.js. And that console.logs, first of all, the result of our first request, which just says that the book has been added. So when we made that post, I sent the information to the server. It wasn't enough for me to just say, hey server, I've sent you information. Don't worry, don't send me anything back, it's fine. I need it to send me back, hey, I've done what you've asked me to do. And we're just leaving it at that. I'm not sending it back saying, hey, thanks for telling me. But now it's confirmed to me, hey, I've done it, and this is the book that I've added. And then with my get request, I've got the list of books. And in fact, I can run this a second time. Because my server is still running, if I run this a second time, there's now 2 books. They're duplicate books. Maybe we could program in that your books can't be duplicated. But now there are 2 books on my server. And if I make a third book, so let's just copy this. And I might go res2. Does anyone here have a favorite book?
Harry Potter.
Harry Potter? 1984? Harry 1984. Good idea. Who wrote that? J.K. Is it Orwell? Or should it be George Rowling? I don't know. And then that book obviously came out in 1983. So if I run it again, because my server is still running. My server, normally when you run your code, it just stops at the end, but it's still running. So if I run it now, there is another book in here, as well as 3 copies of the book. This might be a library. Libraries have multiple copies of books sometimes. Are there any questions about what I've done here? Because this is sort of the building blocks of APIs and of HTTP servers, and I know I've gone through quite a bit in a relatively short amount of time. Are there any questions just at this point? I'll give chat a few seconds to ask anything as well, while I also desperately try to drink some water. Chat is the chat, and you're all, I don't know, fam, I'm out of... Are there any questions from anyone?
So this is running on the server?
Yes, this is the server. This is the server that we are hosting. All right, I don't see anything from chat. So yeah, I walked through how we send requests to the server. And one thing that I sort of glossed over is the fact that we do return some errors. So if the title, author, or year doesn't exist, I return the number 400. And actually, if it does exist, things are getting returned, but they're a different number, and it's sort of the default number, so we don't need to set that. Does anyone here know what these numbers represent? What do they mean? Yeah, so these numbers are status codes, and they are another set of standards that we've all agreed what these numbers mean. So these are status codes that we understand not only because someone might send back a request, and it's a bit weird, it's a bit vague, the error message isn't very good, because humans have to write the error messages. And sometimes humans, we've talked a lot before about the failings of humanity, but one of the things they might not be very good at is actually writing a useful error message. And so these error codes, assuming they're implemented correctly, give us a bit more detail about what's going on. So there are 5 types of error codes. Anything that starts with a 1 is an informational response, which means the request has been received, but it's not done yet. I'm still doing something with it. So I'm letting you know that things have been received, but things are still happening. For anything that starts with a 2, that means that was a success. That means that the request has been received, it's been understood, it's been accepted, I'm done working on the request, and you can be happy that I'm moving on with everything now. 2 is sort of the, one thing that I really hope none of you do, but is really quite common, is that people will just send back a 200, and then in the body of the 200, put a different error code, because implementing error codes is slightly too much effort for people. 3 is, it stands for a redirection. So it means that you can't actually do the action right now. Some further steps need to be taken. This is very uncommon. I've never come across these in the wild before. Has anyone come across a 300 error code in the wild before? I think it's the rarest one. You've used one? Yeah, but I've not actually had anyone encounter them. 4 is one that you're probably relatively familiar with because the most popular error code is one that starts with a 4. 404, not found. When you type something in and it doesn't exist, that's a 404 not found error code. So the request contains bad syntax or cannot be fulfilled. And there's 5, which is when the problem's not you, it's me. The problem's with the server. The server has failed to fulfill what seems to be a valid request. Now you may think that because I've just said 1XX, your error code could be 499, but the codes themselves come with names and come with definitions. So we'll walk through some of the most common ones now as well. 200, that just stands for OK. That's what you're going to be sending most of the time. That is the default message. 201 means it's been created. So that's when you do a post, or when you do a pat or a put. When something has been created, you're probably going to be sending a 201 back from the server. 400 is bad request. That could be because someone's not allowed to do something. So if you're an admin, or if you're a student but you try to access admin stuff, it could be a bad request by 400. Same with 403 forbidden. Sometimes, oh wait, no, so I've got things around the wrong way. Sometimes 403 forbidden is when you're like a student, you try to access admin material. But sometimes what people do is that if I send you a 403 request that says forbidden, what that tells you is, so there is something there, and you might want to try and get into it. So sometimes people actually do lie about this error code and they'll just send back a general 400 so that it doesn't give away too much information. 404 not found is when things just don't exist. And again, sometimes it's not good for people to know that something doesn't exist. And so they'll just send back a 400 to hide this. 500 is an internal server error, so something's just generally gone wrong. and 502 is a bad gateway. I can't remember what bad gateway stands for right now. And there are a lot more of them. There are so many. There's a whole Wikipedia page about all of the HTTP status codes, every single one. And I do, in fact, you don't need to know all of them. You don't need to memorize every single status code, just the general rules about why they exist and what they're used for. I will say, I do have a favorite status code. I'm going to show you my favorite status code now because we have a bit of time. It's 418, which is when you try to brew coffee in a teapot. Genuinely, part of the internet standard is that if you send instructions for making tea to a coffee pot, you get an I'm a teapot request. Error. Can't make coffee in a teapot. And it comes from the hypertext coffee pot control protocol, which is a whole theoretical argument. And there have been genuine debates for years about whether 418 should stick around or not. The answer is yes. That will not be on the exam. I wish I could put it on the exam. Does anyone know what this object is? On the Utah teapot. This is the first ever complex shape modeled on a computer. So not just a simple polygon. It's made up of a bunch of polygons. It's really cool. I've never been to Utah though. This has all been a lot of fun talking about HTTP status codes and whatnot, but at some point you need to actually implement this as part of iteration. You are learning this to do a project. But a lot of the routes in iteration 2 are actually just functions from iteration 1 wrapped into HTTP routes. So you can wrap iteration 1 essentially in an HTTP server. A lot of the stuff for iteration 2 will be going through iteration 1 and wrapping it in an HTTP server. Most of the server stuff is just that routing, figuring out what URLs to send people to, what status codes to send back, what parameters to allow people to pass in, how to do the responses and the requests. If you treat your functions in iteration 1 more like black boxes that just sort of do what you need it to do once you get the data to them, that's generally how you succeed in iteration 2. Because your actual functionality that you need in terms of handling the data, you've written that. That's iteration 1. Iteration 2 is just putting it inside an HTTP server, which makes it much more straightforward if you think about it in that way. If you think about it in the way of you need to re-implement everything from scratch, that's going to be problematic, because then you're going to be writing things a second time, and it's just try to think about it this way. We do also sometimes put version numbers on routes if we're doing testing. So you might say that you have books version 1, and then books version 2, and then books version 3, and so on. This is a principle we're working with in the project, just to make sure that we can keep track of which routes are being worked on when, and what version we're up to. Again, I get to the end of these lectures and I think to myself, there is a lot going on right now. And we want to make this easier for you to work through. So please do be asking questions on the forum, asking questions in tutorials, just asking questions in general, because we can help you make this a lot smoother. That is the end of the stuff that I wanted to talk about, but we do still have a bit of time, so I might just, I'll open the floor to questions first. And if there aren't questions, I might just embarrass myself by playing around with my HTTP server and see what we can do. Are there any questions just in general from people? I see something in chat, one moment. Is the server we run secure? No, not right now. We're just doing HTTP. HTTPS is a secure version. Yep.
I throw error 418 whenever I run.
You can. It's allowed. I'll do it right now. So instead of throwing error, let me come back to my server. Don't want to throw error 400. I want to throw error 418. Let me save that. Let me reboot my server with node books.js. I'll just get rid of the title here. And I'll get rid of these, get rid of that comment. I just want to see what happens if I throw 418. So now let's run a new terminal. And I'll go node request.js. Yeah, a status code. Yeah, there's a server responder with a status code 418. It seems like in Express has gone the dark side because it's not telling me that I'm a teapot. Very sad. But you can program it to tell you that you're a teapot if you want. I don't recommend it. It's not recommended, but you can. Are there any other questions about what we've gone over this past sort of hour-ish? Okay, in that case, I'm going to very quickly show off an example of actually writing a bit more of a function. So let's come back to books.js, and we're getting a new book. We might want to say that if someone submits a title, titles might not actually be in the case that we want. Normally, titles are written, funnily enough, in title case. And I really hope that JavaScript has what I want. I can't remember it right now. JavaScript to title case. Oh, of course. If I want to convert something to title case, is this built in? I don't think this is built in. I was certain this would be built in. Python has it built in. Okay, maybe I want to shout my book titles instead. I'm going to go title equals title dot to uppercase. And now, I'll reboot my server. Make a new terminal. Have I not spelled correctly? Come on. Oh, this is 2 months. Oh, node. Oh wait, I'm still throwing that error. Title, welcome. Maybe I need to reboot the server again. I did promise that I would embarrass myself doing this. All right, I've just completely broken things. Oh, this is actually returning the status code 500, which is not something. So there's actually something wrong with my server. So when I introduce this line of code, oh yeah. Can someone tell me why this line of code isn't working? It's something we learned very early on. What happens on line 11?
Oh, it's a constant.
It's a constant. What can you do to constants? Is it change them? No. So I just tried to redefine a constant here. That's why it's not working. But as you can see, programming in here is literally just like programming any other function. Once you start working on it, it is just a function wrapped inside trying to send information to and from a server. All right. I'm happy to end slightly earlier than normal. This is my last lecture with all of you, so what? Thank you very much. If you have enjoyed it, please do leave feedback because I am a new lecturer. They care a lot about the feedback that I get from students, and I care a lot about the feedback I get from students. If there's anything that I can do to be better, or there's anything you want to tell me, please let me know. On Tuesday, you will have Shaveen, and then in a few weeks' time, you'll have Yuchao, but I will still be monitoring the feedback, and so if you do want any extra resources of new topics that come along, if you want another resource to look at working with these servers, please let me know, and I'll work on doing what I can to make the transition through the rest of this course as smooth as possible. Thank you very much, everyone. I'll stick around for another 5 to 10 minutes. Otherwise, yeah, that's all from me. Thank you. Someone just said, woo. Thank you, Alexander. Thank you.